Alrighty, welcome back to one last examination of concave mirrors. Now, I want to look at the tipping points, the points in between our cases. Our first case was our object was over here, in front of the focal point. Second case was it was between the focal point and the center of curvature. Third case was it was out here beyond the center of curvature. I want to try putting our object at these locations and see what happens. I don't really want to redraw this twice. So I think I'm going to just use a blue pen and a red pen and hope that I don't misdraw it and want to erase it because you can't with pen. Now let's try putting two objects here that are both, I don't know, 5 boxes tall. Okay, first we're going to put one at the focal point. And separately we're going to put one at the center of curvature. And I'm going to be real lazy and not draw two separate diagrams for these. Okay, now for the one at the focal point, if I go to, alright, so if I go from out to my midpoint, and this one's going to be in red. If I go with my parallel ray, then it's going to come back through my focal point. Alright, it's coming back this way, it went out that way. Okay, another ray that we can make is the one through the midpoints. Down to there, that's my mid-ray. Going from here, 5 spots below, 1, 2, 3, 4, 5, right there. It's going to come through that location. I can already see that things are not quite working out for me here. But it's close enough for me to imply what goes on. Now, okay, so it comes out this way. Now, first of all, those don't look like they're getting much closer, but they do look a little further out there. We could draw maybe one more ray. I'm going to draw one last ray here. Alright, center of curvature, which of course is our least reliable one. I don't really like that one because I can tell it's going to do some weird things. Alright, do we have another one? Can we draw one through our focal point? No, we're there. Okay, I'm going to leave it at these two. These two rays are parallel. Okay. They're approximately parallel in my diagram, but in reality, they are exactly parallel. And it turns out that if you are at the focal point and you have a concave mirror, it will never form an image. They will never meet up. Okay? Infinitely far out. Parallel lines only meet up when they're infinitely far out, either in the virtual world or in the real world, which you can't have them both. All right. Next, let's look at our special case where we are along the center of curvature. Now, along the center of curvature, we're going to piggyback on the red line because this one also, I thought it was a blue pen. I guess it's a black pen. This one is also exactly the same height, and so it's exactly through there. Something is a little bit off, looks like to me, because it should point at exactly the same height underneath there. Now let's aim for the midpoint. 1, 2, 3, 4, 5 right here. So for our midpoint, there to there, and here to here. Now I happen to know that where this thing should be, and that's okay. It's close to the midpoint. It looks like it's to right here. We could go through the focal point as a last one. We've got a lot of lines on this page. Let's do one more here. We'll go through the focal point, and then we'll come back out parallel and see where that leaves us at. And once again, things aren't quite crossing where you expect them to. All right. To be perfectly honest, it looks like it's crossing about right here. Now let's calculate this one. if our distance is at the center point, then 1 over the distance to my object plus 1 over the distance to my image equals 1 over my focal point. 1 over my distance to my image is equal to 1 over my focal point minus 1 over my distance to my object. I've said that a dozen times, that's why I'm sounding a little tired. My focal point was again at 9.5. I'm going to subtract off the distance to my object, which I haven't counted yet. Well, no, that's at 9.5. This one's at 18. Ooh, we actually have fractions that will add up properly. So let's do a common denominator. If I double this one, so that's 2 over 18 minus 1 over 18. Well, heck, that's 1 over 18. So 1 over 18 is 1 over the distance to my image. So the distance to my image is equal to 18. In other words, it's supposed to be right here. It's supposed to be right underneath the center of curvature. And I know that, and it's just, this is karma for the one perfect image that I got earlier. This one isn't working out. Okay, so that's where the distance is supposed to, the image is supposed to occur at. The magnification is negative distance to my image over distance to my object, which is negative 18 over 18. So magnification is negative 1, which means even without calculating that it's going to be exactly the same height. So it should go down to 5. 1, 2, 3, 4, 5 should be right here. So in reality, I shouldn't have tried to draw this. I should have just simply tried to calculate it. And so if it's at this point, it ends up being here. Well, that makes some sense, guys. I'm going to go back to a cleaner picture. I'm going to go back to case 2. When my object was between the center of curvature and the focal point, the parallel ray came out here, and this one came down, and eventually it was down to here. Now, if I back this guy up, he is still along that same parallel, it's still found along the same parallel. And we found that when it was beyond here, it was just in this region. Okay? So if it's in here to begin with, it ends up out here. If it's out here, it ends up in here. And so the tipping point has to be right here. If it's right here, it is right here. So if it's at the center of curvature, its image is at the center of curvature, but it's upside down, flipped, inverted, and it is still a real image. It could be cast on a screen, which is very interesting. If we also look at what happens as we approach the focal length, if we went in this region, we had a real image, an image over here. But if we went beyond the focal point, we ended up with an image over here. So at the focal point, it's switching from being on this side to being on that side. In other words, it can't decide where it wants to make an image, and it can't make an image. As a matter of fact, when you're trying to find where the focal point is for a curved mirror, personally, what I usually do is I just look at it, and I bring it closer and closer to my eye until it becomes completely out of focus. Now I'm going to keep my eye on that part there, and if I come just a little bit closer, hold on a second, I'm getting lost. Right now I'm getting nothing. It's either dark or it's bright, and it's not focusing at all. That means I'm pretty much right at the location. See, nothing is happening here. I'm basically right at the focal point because I can't make an image. If I get closer than that, I do get an image. You can see the edges of the light, and it's enlarged. Ooh, I'm zooming in. It's a makeup mirror. Okay? But if I get farther than that, I get an upside down image. Okay? So it went from being upright and enlarged to being upright, enlarged, and virtual to being reduced, inverted, and real. So in between, you get nothing, and that's where your focal point is. I hope I didn't confuse this too much, but that's what you get when you go through the looking glass.